makes sense, but it's like,
Oh.
All right, guys. A little tiny review and then discussion about a couple things you'll need to help you with your homework and create, and then we're going to do a little bit of 4.1. 4.1.
72.
Oh, yeah. What you might have thought I said. 72, yeah. A little bit. So there are problems in the homework that look just like this. See why we put something like this in this book. It's crazy. So this first one, we talked about this, and it's one that people freak out about because you're used to me giving you an f of x and then you just plug 2 in. But why do the work if somebody already did? Right? So real quick, if I gave you, up here, at the top of the page, while I'm thinking about it, here's a little example. What do you get when you plug a 3 in? What happens over here?
2 times 3 minus
Yeah, you just replace all the x's with 3 over 3. Yeah, so you get 6 minus 7 is negative 1 over 3. Now, so what is a point that that function goes through if I graph it? X is 3.
3, negative 1.
Y is negative 1/3, right? When the input is 3, the output is negative 1/3. So a point that this goes through is 3, negative 1/3. So I would plot 3, negative 1/3. So I don't have to show anybody this stuff. If I said, what is f of 3, they would say, well, it looks like it might be about negative 1/3. Because that's where you put the point. That must be what you got. So again, the graph is a visualization of all the answers to an equation. So I don't have to do any work. The work's done. So f of 2, where did they put the point? At 2. Where's the point at 2? 4. There, see it?
Yes.
So the output for f of 2 must have been 4, because that's where they put the point. Where am I going to put a point? Well, it depends on what the input is and what the output I get. And then I'm going to put a point there. And then I'm going to put a different input, get a different output, put the point there. So all of these. So what's f of 3? 1, because that's where they put the point. Because they're the ones that did the work. I don't have to do the work. I just have to look at their work. Do you guys get that? When you plug something into a function, that's the input, that's x. When you get something out, that's the output, that's y. And then you plot the point there. So if you have somebody who already plotted the whole thing, that's all the answers just sitting there. So what's f of negative 2?
negative 4.
Negative 4. I don't even know what the function is, and it doesn't matter because they gave me all the answers right there. So let this problem be simple. All you got to do, when x is 2, what's y? When x is 2, y is 4. There you go. Yay. And again, I'm not trying to make you feel bad if it still doesn't make sense. I'm trying to get you to understand you're making too much of it if you don't quite get it. Right? You're making too much of it, so you need to come see me. Any questions about that kind of problem specifically? Okay, so what would like f of negative 1 be? Don't say anything. Think about it for a second. I love you guys. Some of you guys are like, yeah, so what is it? What's f of negative 1? Looks to be 1 because that's where they put the point. Yeah, why would they put the point there unless that was the answer they got? Bam! And this is kind of funny. So we've already got part of part B. Any x values where the output is 1, well, we already got one of them. Yeah, -1 has an output of 1. Anything else have an output of 1?
3.
3 has an output of 1. So there are problems in the homework just like this. This one is, if x is 2, what's the y piece? So you go find 2 comma what is a point. This one is, if y is 1, what's the x piece? So there's something that's got a y of 1, there's something that's got a y of 1. What's up?
Oh, I'm just like Aaron saying numbers.
Oh,
Sorry.
okay, that's really misleading.
Sorry.
For a teacher when you're doing like this. Oh no, just playing my...
Sorry.
Alright, I like that. The domain of f. So what's domain relate to? The x values that
The highest.
that are used so that I'm allowed to use, right? That's what it really means. The domain is all the x values I'm allowed to use. So am I allowed to use -4?
No.
Why not? Don't have no output. Right, so what's the smallest x value I'm allowed to use? -2, because it has an actual output. So let me show you the 2 ways to write this. The better way to write it is interval notation, but for some reason my math lab wants it written a different way. All right, just deal with it. Hold up. I love you guys so much. Both of us have to deal with it. So from -2 up to what?
3.
Up to 3. That's the last x that has an output. That's beautiful. This is the best way. The second best way to do it is the way that wants me to do it with my math lab. And it really is the idea behind this. The idea behind this, it's -2. It's less than or equal to x. It's less than or equal to 3. So what's a better way to read this? X is between -2 and 3, which is what this means. And the brackets, how are the brackets represented here?
Less than.
Because there's an equal sign. So if they were parentheses, I just wouldn't put the equal sign. It would be a strictly less than. So if you want to write this as an answer in my math lab, and they say inequality, you write it like this instead. These mean the same thing. How are we doing so far? Interval notation is just a little bit better, but oh well. Like I told you, the one thing about my math lab for sure is the format. Okay, how are we doing? Some of you guys have run into this issue. So does that clear that up for everybody? Some of you guys haven't started doing the homework yet. So just keep that in mind, what's going to happen. What about the range? The range I'm going to look at the y's. What's the smallest y output? -4 is the smallest y output. And the biggest y output is 5. I love it. That's the floor. That's the ceiling. That's another way to look at it. Now just take a minute. Just take a minute. Don't say anything. Write that below it what it looks like inequality. As an inequality. Write that below this. Don't say anything. Nobody here is quite that bad. I've had in previous years people that just could not stop. Don't say anything. 4. If I point directly, don't say anything. All right. So what's it look like? -4. Less than or equal to? X. Oh, then yes, it's a B. I like it. Less than or equal to Y. Less than or equal to 5. Like y.
It's the range.
It's the range. And the range relates to
Y.
y's. I like it. Now, I want to give you a kind of problem they do not give you in here, but that you will see in the homework. And this also helps explain some of the weirdness in the homework, guys. Doesn't matter, I was just making it. Why'd you make it, Jeff? Well, my scale is freaky, but we'll survive. Do it like that. There. All right, so let's say this is my function right here. Is that a function?
Yes.
Yes. It's a collection of points where there's no repeated x values, right? There's no vertical line that goes through more than once. But I cannot use interval notation here, because interval notation means you start at a number and you include every number until you get to the next number. And there's an infinite number of numbers between any two numbers. It's crazy. Here, how many x values am I allowed to use?
Negative 2, 2, 1.
How many x values have an output? Negative 2 has an output. So negative 2. So the domain is going to be negative 2. What else has an output? 0 has an output.
No, there's 4 outputs. Okay.
What else? 1 and 3.
How about negative 1?
Negative 1, does it have an output?
No.
I don't see any output. There's 4 points. There's more likely 4 x's have an output. Do you guys, let me stop there. If they were connected, then I would use interval notation or the inequality, because both interval notation and inequality means everything is included between the two numbers. Do I include everything between? No, there's no line. I'm not connecting it. The only answers are this one, this one, this one, and this one. Now what's the range going to be? Negative 2, I like it. 3, okay. If you want to jump around, sure.
0.
Negative 2, 0 is an output. And 1. There's my range.
Wait. Oh, because 3 is up there. That one.
Yeah, sorry. Hopefully you guys copied the numbers. So on the homework, it's going to say, tell me the domain. It's going to say, list the answers and separate them with commas. That's if you have this. Then it's going to say, B, it's going to say, choose this if you want to write inequality. That's if it's connected. Because you want to include every number in between, because the line is telling you all these points in between matter also. Here, this one doesn't matter, whatever this is, because it's not there. There's nothing there, so I can't use that as part of the answer. Oh, you guys look so excited. So domain never changes. The idea of domain does not change. It's all the inputs you're allowed to use that have an actual output. So obviously, does this input have an output? Negative 1.5? No. Does negative 1 have an output? No. So when I write the domain, I cannot let them be included because they don't have outputs. Okay. All right. Let me think. I think that was pretty much all the weirdness in the homework. Is this a function?
No. No, it's not. Absolutely not.
Yeah, why is this not a function?
Vertical line test.
There's at least vertical line that goes through more than once. So for example, an input of 1 has this as an output, it has this as an output, it has this as an output. That's no good. Right? So after 1 second, where were you, sir? Well, I was at the park, and I was in the store, and I was under the ground, and in the subway. Who are you? What kind of X-Man are you? Please give me that power. Right? That's bullshit. So it doesn't make physical sense. That's what it relates to. Vertical line test is the visual analog of the definition of function. Oh my God, it's a sentence. What's the definition of function? Every input, x, can have only one output. So a vertical line, if it goes through more than once, a vertical line is an x value. X equals this vertical line. If it went through more than once, it would mean that that input has more than one output. That's why the vertical line test is the same thing. It's a visual definition of the actual definition of a function. Okay. Go full Tai Chi. So, I mean, to answer this question, you could just say, not a function, does not pass vertical line test. It's a beautiful way to answer this question. Because I will say, is it a function, why or why not? And you better tell me why or why not, or else you'll lose the bulk of the points. 50-50 shot with yes or no. So I need the explanation. Okay, well, look at all these answers. Ooh, answers you got here. Is there anything else freaky? Not really. Nope. All right. So now,
I didn't.
what's up?
I typically make me.
Okay. Okay.
I have a question.
Yes.
For number 26, I know in the homework it has like negative infinity and infinity in some of the numbers. Is that when there's also a point at the end of the next one next to it?
Yeah. Oh, this one. All right. Good question. Do you notice how these arrows mean they keep going forever in this manner?
Yeah.
So when I think about domain for this problem, this is number 26 back on page 73, before we get to chapter 4. Can I say that -6 is not a part of the domain?
No.
Because if I go down and I keep this going forever, it will. So is there any x values that are left out? No. So that would be from negative infinity to infinity. Every x value has an output. Because if you just let these keep going, every x value you can go down and find an output for it. Nothing's left out. What about the range?
Negative infinity.
Yes. So the range, what's the lowest output? Well, the lowest output would be negative infinity. Keeps going forever. It's down. What's the highest output? 5. There's a definite peak to this, right? And what do I put on the 5?
Bracket.
Bracket, because it's a closed circle.
If it's an open circle, what do you put?
If it was an open circle there, I would put parentheses, because I couldn't include it then. Yeah. There was one more thing from the... Oh, okay. So I don't think they have that kind of problem here either. These evil people. Oh, that's right. That was on my little handout.
Yeah. I haven't done it
So remind me, the domain is what again? All the x values I am allowed to use. Is there an x value that would make this function freak out?
Negatives or positives.
Yeah, 0 in the bottom would make this freak out. What value of x makes a 0 on the bottom? 7. So am I allowed to use 7? Of course I can't, because there is no answer for 7. It's undefined at 7. Does that make sense? Is there a point for an input of 7? No. So then it's not in the domain. It doesn't go anywhere. It's undefined, so it's not in the domain. So what would the domain be then? Well, in English, the domain, remember, is everything I'm allowed to use. How many things am I not allowed to use? One thing. So the domain would be all real numbers except 7. Is that a door creaking or a baby? Okay. Now, this is where I left it off for the people that have done the in-lab worksheet so far. But let me show you how to write this in interval notation. Oh, shit. So if I want to use all real numbers except 7, I can use every number that's below 7, or every number that's above 7, right? I love it. And you guys look at me like, you are a genius, sir. That's amazing. Thank you for saying what you just said. But the reason I'm saying that is because that's what it looks like in interval notation. So I can use every number from negative infinity all the way up to 7. Stop. I don't put a bracket because I cannot use 7. That's the whole point, right? And then there's a symbol for or. It looks like a little U. That's a symbol for or. Or 7 to infinity. Now me, personally, when I see this, I look at this as skip. From negative infinity to infinity, skip 7. That's what I read that as. Ooh, some of you guys are loving that shit. Oh well. So all this is saying is there's a 7 you can't use, so I can use everything below it, well that's negative infinity up to 7. Or I can use everything above it, 7 to infinity. So that's how you write it in interval notation. So what if there are 2 things I couldn't use? Well then there would be 2 of these little skippy dudes, right? Skippy dudes. Okay, that's enough of that. Oh shit. So, do you guys remember, if you weren't here for this day, then it'll be interesting to see your reaction. Do you remember that thing we talked about with the tree stump defense system with the Korea-shaped missiles at our house? Okay. If you weren't here that day, it's too bad. And I was talking about the fact that there's an equation for the missile, and then this equation for my anti-missile. Right? And I want those equations to meet. Now, the actual math is a little bit harder because not only do they have to meet, they have to meet at the same time. Not like, oh, there we go, and look, I crossed your equation. We're good. They have to meet at the same time. So the math is a little bit more difficult, which you should expect. It's freaking well trying to destroy missiles before it kills us. It's going to be a little more complicated. But we're about to get into something very related to that. We're going to say, what's the answer if I have 2 lines? And I need them both to be true. So what's the answer if I have, let's see, what's kind of weird, this is all good. What's kind of weird about one line by itself is how many answers are there to this line? How many answers are there to that equation?
Infinite.
There you go, infinite number of answers, right? How many answers are there to this other equation? Infinite. So I don't, just to remind you guys, I don't list all the answers. What do we do to give the answers? We graph it. I love it. So if I graph that first line, it'll be a line. And the line, all the points it goes through are answers to that equation. On top of that, I graph the other line. And all the points it goes through answers that equation. So what's going to answer both equations at the same time? Yes, that one point where they meet. If they meet at one point, that is the one point that works in both equations. Does that make sense? So where the lines intersect, that point is on both lines. So that point works in both equations. That would be the answer to this, what we call system of equations. So, for example, this would be as if I said, I got 2 kids, their ages add up to be 6. So how many things could that be? 1 and 5, 2 and 3, right? 3 and 2. You guys with me? But then I say, all right, the difference between their ages is 2. Now that's new information. In fact, let me get more general here. How many unknown things are there in those equations? 2. The x and the y. So does it make sense that if there's 2 things I don't know, I need 2 pieces of information to try to figure them out? So it's sort of like, I always think of this as like a CSI kind of thing, like a forensic scientist. What are they trying to do? They're trying to get evidence, and the more evidence you accumulate, the more of the shit you don't know you can figure out. Right? Well, how long was that guy in the alley dead? All right, let's test him, let's see what temperature he is, and let's figure out how long he's been laying there. All right, then who was around at the time? Well, let's get the cameras and let's talk to people and see who was around then. Do you guys, and I'm trying, there's a lot of shit I don't know. When he died, who killed him, why'd they kill him, who is this dude? You guys with me? So the more shit I don't know, the more information I have to gather. In math, it's very specific. If there's 2 things I don't know, I need 2 pieces of information. If there were 3 variables, I would need 3 equations and that I could figure out. Okay. So graphically, just take a minute for me. Let's do this. See if we can do this 2 different ways. Tell me some points that work in this graph here, this first one. So do you remember we did this the first one?
4 minus 2.
So 4 and 2. 6 and 4, I like it. 3 and 1. 5 and, no?
Oh.
3. They just have to subtract to be 2, right? And of course, if I did this, I could go forever. My guy. What about this one? What's the answers to this one?
2.
3 and 3, I like it. 4 and 2, interesting. 5 and 1. 6 and 0. Right? Okay. Do you already see the answer? What point works in both? 4 and 2. I like it, right? Now, can you do that every time? Oh my God, no. These are just really simple. Like there's 1, the coefficients are 1. It's really easy. So take a minute now and graph both of these on this graph. Graph the first one, finish it. Graph the second one, finish it. I would prefer if you graphed it using mx plus b, but you could actually plot these points. But try to do mx plus b just to do a little review. Solve for y, get the slope and the y-intercept. Oh, Jeff, you dork, why are you doing it? Too bad, try that. Try to graph those two lines using mx plus b. So this will be y equals x minus 2. And this will be y equals negative x plus 6. You see why they gave us the 6? This is minus 2.
Negative 1.
Yeah. So let's see. This needs to be something you could do very quickly. Using mx plus b form to plot a line. This first line, let's call him line A. Call you line B. This first line, what's its y-intercept? Negative 2. I like it. 0, negative 2 is even better. And the slope tells me to go up 1 over 1. Let me just do that a few times and you'll see why. Oh, I'm feeling crazy. Okay, that's enough. Oh, I forgot my little... I actually got a ruler and I forgot. Too bad, Jeff. Okay. So that's line A. What about line B? What's its y-intercept? 6. And then you go down, 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 down. Hey, see, that's why I stepped more steps with the slope, because then I can really see. If you just step one step and then draw, you know that your lines go like this. And the other line's going to go, and it's going to just connect some weird place. If you give yourself a few more steps, then you see exactly where they meet. And of course, where did they meet? Yeah, 4, 2, the answer that we already knew, just by looking at the points, but you can't always do that. Don't get too excited. Let's see if they did something weird there. No, they didn't. Good. Well, let's see. Try number 2. The same way. Don't do it this way. Do it mx plus b and graph them and see if you can see the answer. So the first step is just graphing 2 lines. This is something you should be, by now, decent at. So I want you to realize
I don't, why is it so?
each part of this, there are two parts to this problem to start with, and they're both just graph these lines. That's it. At this point, you need to be able to graph a line relatively quickly. Is everybody cool with solving for y here? Is that cool?
Yes.
And real quick, a lot of you guys forget the poor little negative on the y, so let me let you in on a little secret. I just add y and subtract 4. These actually just end up switching places. So y equals 2x minus 4, kabam. If I add y and subtract 4, I won't have a negative y that will mess me up.
Yeah.
So many of you guys forget the poor little negative dude, then you get the wrong slope, the wrong everything. If you don't like what I just said, just try to remember the negative. What's this first guy's y-intercept?
2.
First guy,
Oh, sorry, negative 4.
negative 4. And the slope tells me to go
Up 2 over 1.
up 2, over 1, up 2, over 1, up 2, over 1. Just do a few extra. Oh, scheisse. Learn how to cuss in many languages. Is that cool? I mean, just graphing that line. Let that part be easy. What do I got to do now? I got to graph another line. Sweet. Another easy thing. So what's the y-intercept? 2. And the slope tells me to go down 1, 2, 3, 4. Over, holy crap. So what's the answer? Careful. 1, negative 2. So you're going to, preferably you would write a point, but you could also write x is 1, y is negative 2. That answers that system of equations. How are we doing? What's any questions so far? So let me let you guys do number 3. 3 is a little freaky.
Oh, sweet Jesus. Why do we gotta practice so much?
So do number 3. Let me pass back some stuff I haven't been able to get back for a while. Soleil, Brooke. Brooke was here momentarily. Monique, Josh Calderon, Josh, Trey. Man, if I'm not here on the test day, I never get to see these guys. Ayana, Davis, Andrea Gomez, or Andrea Gomez, Marco Hanna. Just gonna mail these to their house. Zainub, I'm sorry, I shouldn't be saying that. Zainub, Hashimi, Zainub, huh?
Is that food?
Zainub, Hashimi, nowhere near Fanu. I know it's Fanu. Kazan Holt. Eric Lopez. Hey, no way.
Me too. I'm so.
I haven't Maldonado.
No, he's trying to change the subject now.
Belinda, Matt,
Most of my thing is the food. I missed
Caitlin
that.
Morales,
I'm trying to change the subject.
Jackie, Pittman, Gianna Polenko,
Never asked.
Yes, I did.
Sierra, Francisco,
This was 2.
Cisco,
Okay, this obviously is.
Saul, and
Why did my box look so big? What's your box?
all right, what do you guys see on this one? Parallel.
Are they? Oh,
Yes.
God, every day like twice.
I told you it was freaky. So the slope, y-intercept in this one's -1. Slope tells you to go
Down
2 over 1. Slope, the y-intercept in this one is 2, down 2 over 1. So if the answer is where they meet, and they never meet, what's the answer? No solution. No! No solution. So just think about it. If the answer, so there's 3 things that could happen. The most common thing is they meet at one point. Or they could be parallel, so there's no answer. Or they could actually be the same line. It's like if I said I'm twice as old as you, and then I said, oh, you're half as old as me. Did I just give you 2 pieces of information? No, I gave the same piece of information twice. Great, thanks, Jack. We can solve that mystery. You guys understand? So if they give me a line and the other line is the same line, then there's going to be an infinite number of solutions because I haven't pinpointed which solution is the right one. I didn't give you 2 pieces of information. So you can either have one answer, no answers, or infinite number of answers. All the points on the line would be the answer there. Oh, you guys love this. I know. So you guys know the algebraic way to do this, and you're like, do that.
Let's do that. Let's do that.
Where do I start?
So think about this. My graphs leave a lot to be desired, right? And some of your graphs somehow are even worse. But if I had to do this by hand, and the answer was 2.97334, comma, negative 1.29000007, I ain't getting that answer. So the biggest issue with this method is it relies on your ability to be precise. And we're humans. We can only be so precise. Maybe I can get like a 2.5 answer. I can see that. But the minute it's more than that, no, I can't be that specific. My resolution isn't good enough. Are you guys understanding? I love some of you guys are like, yeah, especially yours. Keep it yourself. So there's got to be an algebraic way to do this. Because the algebra will give me whatever the hell the answer is. Algebra has no problem. Right? You might have problems with algebra, but it has no problem with this. So let me just give you a little preview of the first method, and then we'll head out. This first method, normally students get it pretty well, because at this point, especially with functions that we just did, you should be extra used to plugging stuff in, right? F of 3, you put a 3 in for x. Now notice what this equation, number 1, what the equations say. I need x plus 3 times y to be negative 28. Okay, that's one piece of information. And then they say, oh yeah, y is negative 5 times x. Beautiful. I know that y is negative 5x. So I can rewrite the first equation using the information from the second. I can use both of them together. Does that make sense?
Yes.
All right. See, so I can rewrite this first equation. It says x plus 3 times y, but what is y?
Negative 5x.
Negative 5x. All right, now, let me just stop there. You got to let me know if there's any issues. A system of equations are 2 pieces of information somebody told me. I need to use both pieces of information to figure out x and y. So I use the second piece to rewrite the first piece. The second one says y has to be negative 5x. So I just replace y with negative 5x. Now, what's better about this equation than what it used to look like?
Has one variable.
It only has one variable. So what's this? What's 3 times negative 5x? And what's x minus 15x?
Negative 14. No, it's negative 14.
Negative 14x? I like how I paused and just let you guys just make mistakes. You had it right the first time, but it didn't stop you. And then, of course,
Divide by negative 14.
Get 2.
you got 2.
Those. She like has her.
Now, if you circle that and keep going, why are you wrong?
You gotta plug it back in.
Yeah, you got to know what y is. The beautiful thing about this method is I have an equation. I can plug it in either one. Why does it not matter which one I plug it into?
Because they both have Y's.
True. They both have a place for it to go, but more importantly,
Easier.
the answer is the point that is on both lines. So it doesn't matter which equation you picked. But the second one is freaking easier. It's already solved for y. So if x is 2, y is negative 5 times that. That's what that says. Which is negative 10. Now if you stop there, I'm okay with it, but what's a slightly better way to put the answer?
And negative, or 2, comma 10. Negative 10.
Why is that a slightly better answer? Because the answer to any system of equations will be a point, or a set of points if there's more than one answer. I won't take points up if you do this, but that's just a slightly better way to put it. So you guys try number 2. Let me just help you out a little bit on number 2. What's kind of wrong with number 2? Number 1 is really nice. There's an equation that says y equals.
Yeah.
Number 2, is there an equation like that?
No, so
No.
you just solve one for one.
You can solve for x or y in one of them and then plug what you get in the other. Let me see how far you guys can get with number 2, and then we'll head out just about on time for once. Yay. Instead of early. Spoil. Alright? So I hope to God, why would I not want to solve the first one for x or y? Because you would get fractions, and if I force you to, you should be able to do it, but even I'm not going to pick that, because I'm human, that's somewhere I can make a mistake. The second one is better, because I have one coefficient. There's not going to be any fractions. And I should solve this for x, because all I have to do to get that for x is to do what? Add 1. So I know that x is y plus 4.
Plug that into the first equation.
So this is the second equation rewritten. You plug that back into the other one. A big mistake people make is they plug this back into itself, and you always get like 4 equals 4 or something. It's what's known as circular logic. Right? So don't do that. You got to use both pieces of information together. So take the second one and plug it into the first one. So rewrite the first one. It says 3 times x. But what's x?
Y plus 4.
Y plus 4. Right, let me write the first one. The first one started off like this. 3x plus 2y equals 27. But I know that x is y plus 4. I know that. So then I replace x with y plus 4. It's a better piece of information, because now in this equation I only have y's. I can solve for it then. So sort of a very underhanded, kind of sneaky way, I just kind of replace somebody. It's sort of like that Invasion of the Body Snatchers thing. moving, right? Just sort of, your next, now it's a y, haha. It's a very subversive way to do this. The other method we're going to look at later is very in your face. Yes?
How you did the first step, x, y, x equal y plus 4?
Just by adding y.
You just add y to the other side.
Solve for x, so I add y. It doesn't matter what you solve for, it's just a little bit easier to solve for x. And then that I can plug in. Now, what do we get? You guys are all packing up. 3y plus 2y is 5y. 3 times 4 is 12. 5y equals 15, so y is 3.
Yeah.
So then what's x?
7.
X is 7. So then what would the answer look like?
7, 3.
7, 3. Oh my god. Alright. I'll see some of you guys here in a minute. Huh? Oh, yeah. That's fun. Can I take my I do this kid once and he said his teacher told him, I'm a quarterback. You gotta catch the ball. And I said, ball for right, this was pathetic. Crazy.
I just clapped because I was like,
No, I'm not done with those. I got this here though. This is something here to make corrections on that. Sure.
Here you go. Confirm the time for the makeup test yet?